All right, cool. So this is a little informal, and I spent a lot of time recently getting 0.10 out the door. So I'm just going to let you guys decide. What would you like to hear about? I could some topics that came up were something about domains, changes in Node 0.10, or anything else. You want to hear about new shit? Okay, we go. Okay, well, I don't have a whole lot of time, so I mean, and there's a lot of new shit. So, okay. So, also, I think it'd be fun to show some code rather than doing the. I have some slides about streams too, but I'd rather show you guys some actual code. Oh yeah, 0.10. That's like the big thing. Okay, so clearly this is what I need to talk about. I will tutor you guys on domains later that asked for it. So anyway, yeah, streams. So I did actually give a talk on this not very long ago. Let's go to public presentations. Hopefully there's nothing embarrassing that you guys are watching here. And the one in Korea was actually the best. So, that's not where it starts. Gosh, I hope I'm good at computers when I grow up. Anyway, so there's a lot of stream things in core. I know I lied. Said I was going to show code and not slides, but I do have some slides. So streams are kind of like Legos. You can just take the IO from one thing, hook it up, put it into something else. You can build these like bigger structures that are also streams, all like using this one abstraction. It's kind of nice. Before we had streams, we had this really crappy like domain specific names for things. Like in FS, it was called body, but then in like TCP it was called chunk, and in HTTP it was called body because it was like the request body event. All different interfaces, different names, that kind of thing. And so the first implementation of streams was just we had a chunks coming in. You could write them out, and it sort of worked. Added a util.pump method. The big thing, though, with streams that makes them exciting is that you have this pipe method. So that's kind of an abstract way to say, take this stream, hook it up to this other writable, and now you can pass data around real easily. And the problem is that streams up until now were pretty bad. So we had immediate data events. Pause was strictly advisory rather than actually pausing. Everybody did buffer wrong, and some other problems. So have you ever been bitten by this? Anybody? No, you're all Node experts. So the problem is that it's pause doesn't actually pause. There might be one other data event that comes through. So we fixed that. And basically we have this read, which returns a null, either null or a buffer. And then you can take that and send that down the line. And for implementing your own stream classes, you can just implement this one method, and now you have a like fully functioning stream thing that does all the correct buffering and everything. And we're using that all throughout core now, so it's actually really pretty nice. The API here is like it's wrong. That changed. But basically, this solves all of the problems that we've had. It's if you want to rather than pause stuff, you just don't read from it until you're ready to start reading, and then it's fine. And also there's this transform class that you can use to, if you have something like zlib or crypto, where you have some input, you do some magic on it, and then that creates some output. So then what you do is there's a nice class for that. Also, there's a lot more consistency in going through this. I found a lot of cases where like the same argument could mean subtly different things in two different streams, or some of them had a set encoding method, some don't. It was a total nightmare. And so now they're all using the same classes. It's a lot more consistent. V8 seems to like that a little bit better. And so the problem is that like some modules will break. So we added some backwards compatibility stuff. Backwards compatibility is the worst thing in the world. It's great for you. It sucks for me. It's it's just an awful lot of work, and like it's not fun work. It's it's terrible. But I think the benefit is worth it, because now otherwise, like, we'd leave the whole Node community in the dust, and it'd be like, Perl 6 or something. So there is one unavoidable edge case. And since we've released 0.10, I predicted this was going to be a problem, and it's a problem, but there's just no way around it. The issue is if you add an end listener, right? So right now, if you get an HTTP request coming into your server, and you just add an end listener, like, that listener is going to get fired eventually, right? Eventually the request will end. Well, not so much now, because we wanted to be able to do this thing where you could like go hit a database and come back and have the stream not have been like, expired in the meantime. So we don't actually read from the socket until you start reading from the request. So if you add the end listener and you don't ever read it, you don't pipe it, you don't add a data listener, then it'll just sit there paused like forever. And so a couple modules are seeing some tests fail with that, but mostly it's not so bad to work around. Most of the time you actually do care about the data, and you'll just already be adding a data listener or calling read or piping it somewhere. Or you can call stream.resume, which does the same thing. Just says, okay, I'm in old mode, flow all the data through. So, oh my God, I was so hopeful. Look at this. You see this right here? December or January? What was I thinking? So what happened was some of these... I love this. I haven't looked at these slides since I gave this talk, apparently. But there were some performance issues. They were clearly solvable. We solved them, but they took a lot longer to solve than I thought they would. In the meantime, so those flame graphs, those were fun too. In the meantime, what we ended up doing was actually, we ended up doing much more thorough benchmarks. So we have this nice little make bench script. I don't know how well you can see that, where you give it two different binaries of node and you run them, and it'll go through like every combination of all the options that you specified and run this test. And then like the compare script, actually, you can tell it to run each test 20 times and then take the highest quartile and the lowest quartile, throw those out, because they're mostly, my Twitter client decided to check for new messages while the benchmark was running or something stupid like that. This proved to be really, really useful. There were some other tools that actually Joyent has made some flame graph stuff that you can really use to zero in on unnecessary work that you're doing. But in the end, it came down to good old-fashioned just like reading the code and looking at all the V8 optimization, debugging stuff, and running benchmarks again and again. So that FS one was really exciting, I thought. I don't know if you saw, but 1726.12. That's a lot of percent. That's a lot of percent faster. It's only if you're reading a ASCII file. What is this? Oh no, this is using buffers, but in chunk sizes of 1024, which like no sane person would ever do anyway. But that's one of the reasons why benchmarks are fun. You get to do insane things. The HTTP benchmarks, we got them down to where they're, within a margin of error of 0.8. They're usually a little bit faster for most use cases, except when you're responding with a very, very, very large ASCII string message. Then it's like, okay, so that's kind of an edge case. Most of the time you're writing slightly smaller messages or multiple chunks. Um, the net stuff is really bizarre. You see, there's a lot of red here, but it's the green is bigger than the red. So, by D&D rules, you gained more hit points than you lost, right? Unfortunately, it doesn't quite work that way. But, everything that's on top of TCP is actually running really, really well right now. These tests, what they do is they take and they just slam bytes through a socket as fast as they possibly can. The reason why this got a little bit slower, or my best guess as to the reason why this got a little bit slower, is that we're actually doing a little bit more work on each iteration of the event loop. So every time we call from C++ into JavaScript, there's a few more extra things we do. And the trade-off of that was we kind of judged to be worthwhile. And we made up this speed difference in other places. So the extra stuff that we're doing that I figured was worthwhile was process.nextTick now is more immediate, more consistently. So anybody in here not familiar with process.nextTick? Not know what that is? Okay. So it's like a set timeout that happens right now, right? That's faster. Because it was implemented as a higher priority timer in Node 08 and before. And so most of the time, if you do a process.nextTick and you also do a set timeout, the next tick will definitely happen first. However, even a high priority timer will not actually preempt the event loop. So if you have, 100 people all requesting stuff from your server at the same time, and you do a process.nextTick, like one of them is going to sneak in there. And so this led to a lot of kind of weird edge case bugs, even in the HTTP implementation itself in Node, where, we have these race conditions that could only ever fail in production when you're getting hit by a lot of users, which is like the worst possible time to have that failure. Yeah, you work at Voxer, right? Yeah, you've had these bugs. No, you don't? Oh, I'm thinking of somebody else. Yeah, Voxer bumped into a lot of these. They had problems with this. Anyway, so that's process.nextTick is now immediate. If you set a next tick, it will happen right after the run to completion. Another thing that changed was actually that domains are more of a first-class citizen now. So actually, anybody ever look at the code of, oops. There we go. Yeah, it's a little nicer. Anybody ever dig into the code of the source of node.js in the actual node.js file? All right. So this is actually kind of interesting. Process.FatalException. Whenever Node has an error, right? Whenever we have some kind of error that's, like a thrown error, you tried to offset a property of null or call a function that's not a function or whatever. What happens is V8 has an API that we call into in C++ that lets you say, whenever there's a fatal exception, call this function. And so in that function, we call this process.FatalException. So we're actually kind of calling from C++ into JavaScript. In this process.FatalException, we do what it used to do is just emit the uncaught exception event, and then if you handled it, fine. If you didn't, we will, crash and burn horribly. Oh, look at this. I love seeing messages from myself about stupid things I'm doing. Now what we're doing is we're actually in this fatal exception handler. We're going to we check to see if there's any domains. If there are any domains that are currently active, then let's emit the error on that thing. Otherwise, we emit the process.onUncaught exception. So it was always kind of weird that if a domain exists and if a domain is in use and it handles the error, then why do we also emit uncaught exception, right? Because you kind of you caught it in the domain. So now that's actually taken care of. So this leverages the fact that the event emitter.emit function will return true if anything handled the event. So if the domain has an error listener, we can detect that and not emit uncaught exception. If it is not caught, then we emit uncaught exception, see if anything handled that. If not, blow up, crash the process. I have some notes on my phone here. Benchmarks, covered all those. Oh, right. So I also wanted to tell you about this, which is awesome. Anybody in here familiar with Jenkins? Yeah, you've all used Jenkins. Yeah, raise your hand if you've ever cursed like loudly enough to make your coworkers wonder if there's something wrong with you because of Jenkins. I don't think it's Jenkins' fault, really. I think just continuous integration is hard. It needs to be someone's job. It's not a problem that will just kind of solve itself, or like you can get around with 50% solutions. Like you need somebody taking on that pain and working to make it better. And so it took a long time to find somebody, but we did actually hire somebody at Joyent whose job it is to do continuous integration for a node. And this is already in the last couple of weeks already has yielded really good benefits. We've got these little nice graphs, and like we're going to have these benchmarks getting run in a very thorough way, like every night. And also nightly builds happening every day of the Node.js project. So we'll be able to actually like give people binary versions who are not so familiar necessarily with Git, right? I mean, early on in a project's lifetime, you can get away with saying, hey, can you try the latest Git master? I think I might have fixed your problem. Well, if you're dealing with somebody who never used a command line, who just clicked the install button and now they're using Node, like that doesn't really help them, now that you're asking them to learn a lot of stuff in order to give you that feedback. So it doesn't benefit us either. Having nightly builds is kind of nice then. So let's see, what else? Anybody have any questions? Complaints? We have used Travis in the past. There are two problems for us with using Travis. The first is that Travis doesn't support SmartOS, OS X, and Windows. I think they're working on Windows, or they might even have it by now. I'm not sure. But it's Linux only, which is like, okay, that's 25% of what we care about. The other problem is that building Node from scratch takes a very long time. And
20 minutes.
What's that?
You only get a certain amount of time.
Yeah, you only get 20 minutes. And 20 minutes is plenty of time to build Node if you have, from scratch, from a clean checkout, if you have like a pretty powerful machine. Travis zones are not very powerful machines. So we were hitting the 20-minute timeout every single time we pushed a commit, and it was just stupid. So eventually we turned it off because we were getting these like messages into our IRC channel like, oh, it timed out, you failed. And that was just kind of like, the thing is like bad CI is actually worse than no CI, because with no CI, at least you're not covered. With bad CI, you're like, another failure. I guess I'll just keep not caring about that. You learn to tune it out, and then it's not helpful to you at all. It's like having tests that fail. Like, don't have those. Make a decision, either get rid of them or make them pass. And in this case, as you can see, we have some that are not passing. But that's getting worked on. It's on our to-do list, on our list of things that we're doing. Another issue with Travis is like we really want a lot more than what Travis can deliver, right? We want nightly builds. We want benchmarks getting run, and eventually I want to automate the entire Node release process. So, we just write up a change log and push it, and like have it actually create all the binaries, upload the website, do everything, end to end. That'll reduce a lot of the work that I do day to day. So that'll be nice. Let's see. Any other questions? Yeah.
What should we be excited about coming up in the next releases?
Oh, you're the guy I planted, right? So, thank you very much. I'll give you
$50 afterwards.
Yeah. No, don't worry. I haven't forgotten. I'll PayPal you or something. So the question was, what are we going to look forward to in future releases? Let me give you. I would like to answer that question with a question. So, what's the name of this function right here? You see this? Socket close listener. That gets called when a socket closes, right?
Yeah.
Let's see. And there's a request here, and there's a rec.emit close. Makes sense. There's a rest, which is like we're going to check. Okay, there's a rec and a res. Am I on the server or the client right now? Anybody know? Because I honestly don't know. I wrote a lot of this code, and I don't know. Like, it is a nightmare. Our HTTP implementation is like, people always tell me like, oh, but Node has the best HTTP implementation of any other language. Like, I'm like, sorry for those other languages because Node's is terrible. The real problem is like, so most HTTP servers are either they're not an HTTP client or they're not a very good one. I rather like the way that Nginx is like took a stance for a long time that like they're only going to do HTTP 1.0 in the client. And even still, I mean, it's not a very full-featured HTTP client. It's just enough to be a proxy. Doing a full-featured HTTP client is really hard, and also being an HTTP server is also pretty hard, and we focused way more on the server side. The client and the server reuse a lot of code, which sort of makes sense, but it doesn't make sense for them all to be in the same file and like completely everybody's up and everybody else is underpants, and it's really kind of a nightmare. There's also in the HTTP client, there's really no way to do like reasonable keep alives. So what you really want to do is you want to say like, I want to have no more than n connections, but go ahead and scale up and like keep this many around all the time, right? And try to reuse sockets. The way that we do that's not very good right now. It picks 5 as the number of sockets to keep open, which is like always the wrong number. I mean, you want either 1 or infinity, right? Like you want to basically get as far from 5 as you can in either direction. And either one of those would be a better default. So anyway, I'll stop bitching about it. The long and short of it is 0.12 is going to be about rewriting this file and breaking it up and implementing a socket pooling implementation that's actually like useful and good. This will also be nice for stuff like database connections or like the Redis module that do actually want to maintain their own sort of pool of sockets and reuse them so you can get better performance and stuff, not have to be continually doing the socket setup, which is really crazy expensive. And so we should do that, and there's going to be like a net.create pool, and HTTP will use that, and it'll be kind of nicely organized and separated. Other than that, I don't really want to do too much in 0.12. Fedora and Dutney has been working on something called TL Snappy, which is like a faster multi-threaded TLS implementation for Node. So that's a hard task to take on. I don't know if it's going to get into 0.12 or if it's going to get pushed out to 1.0, but it might. He's going to keep working on it, and so it's basically a matter of when it's ready. Also, these things will be happening outside of core as well, sort of like the readable stream module was. So, there's going to be a standalone NPM package that you can install that will be this socket pooling library, and you can use it as a standalone utility outside of Node 0.10 or outside of Node 0.12. Any other questions? Yeah.
Is the new socket library is socket 2?
I'm not sure what we'll call it yet.
Okay, I'm wondering if it's going to like have some awful name forever, or if it's going to be like deprecated or the current API, or are you like detecting how I'm using it to try and figure out whether like what API?
Oh, you mean the new? Well, you're going to have to It's still very fuzzy, right? Like we haven't really spent much time actually designing the API, but what I kind of imagine it'll be like is you'll actually do net.createPool.
Yeah.
And there will be a net.pool class that you'll be able to implement and extend if you want to. And then from that thing, you'll be able to say like, hey, give me a socket. And it'll hand you one. And if that one actually gets like a econ reset it'll detect that it's part of the pool and then do a reconnect and like swap out the handle underneath,
Okay.
which is, I mean, it's tricky and magical, but you kind of need that functionality, right? Like
Yeah.
the whole thing with socket pooling is like, if I keep a socket open to the server forever, and browsers, I mean, every browser has to do this. If I keep a socket open to a server and I'm not actually using it for a long time, I can set some reasonable timeout. I can say like, hey, you know, after 2 minutes, if there's been no traffic, go ahead and throw it away. But the server might still destroy it in the process when I'm just sitting around. And it's common practice in TCP to just like, I make a connection to you, and I'm... hey, okay, so now I made that connection. Let's start talking. And you can be like, I don't know who you are. Like, I've forgotten all about you. So the way to do that is you'd send a reset packet back to me when I do that, and then the correct thing for me to do is to instantiate a new connection. So all of that has to happen behind the scenes, and it has to work still like a socket would if you had just set up a connection. Anyway, does that answer your question?
Yeah.
Cool. Anybody else? I guess that's it.
Thank you. So, got a choice, 5-minute break, and then we'll do another presentation.